Hi, I'm Mr. Huber, and in this video we're going to look at tangent alpha is equal to 1. Well, look, alpha is arc tangent of 1. Alpha is arc tangent of 145 degrees. Well, do we need a calculator for this? No, we don't, because we know this table. If the tangent is 1, then we have 45 degrees, one value. And as before with sine and cosine, this equation has in fact not one solution, it has infinitely many solutions. Now look at this. GeoGebra will help us. Look, I can switch on and switch off tangent. So I switched on tangent now. Now look, 45 degrees, more or less. You see, tangent is 1. Well, do we have another value where tangent is 1? Let's go around the unit circle. Well, your tangent grows as your angle grows. And now, as you cross the 90 degrees, your tangent will be down here. It will be negative. Look. Will be negative. Now, as I cross or as I pass the 180 degrees, it will be over here again. Now look, at what point is it 1 for the tangent? I've passed 1, it's at 225. Now, is this a coincidence? No, because you have 45 degrees here, plus 180 degrees, and you're here again, okay? So you could say, let's just jump between these points. Well, from here 45 to 225 by adding 180 degrees. So you have one basic solution at 45, and then you add 180, you get your second one. And with these two, you could add 360 if you wanted to. So let's just write this up for a moment. So you could say it's alpha is 45 degrees plus k times 360 degrees, k an element of z, and alpha is 45 plus 180, 45 plus 180 degrees. That's 225 plus k times 360 degrees. K is an element of z. So you have these two solutions. But you could do it in an easier way, because you could say, let's just do it like this. Alpha is 45 degrees plus k times 180 degrees. K is an element of z. Why can you do this? Now look at the drawing. Either you go to 45 and you add whole terms, okay? Or you subtract whole terms. So you have one basic solution and the other basic solution is 225, and you add or subtract whole terms. But you could also say that if you just jump from this point to this by adding 180, or from this to this by adding 180, it's the same thing. You get the same tangent. So you just start at this 45, and you know, well, now look, I hit it exactly. I don't know how I did that, but well, it worked. And I can go to 225 by adding 180, and then you add another 180 and you're here. And that's in fact 360 degrees plus your 45. And that's what we call the period length. So it will repeat itself after 180 degrees. Whereas sine and cosine from before, we had to add to 360 degrees each and every time. And we weren't able to just jump by 180 degrees from one point to the other. So now the possibility with tangent is much easier. It's just 45 degrees plus half rotations. Okay, so from 45 to 225 and from 225 back to 45 if you want to. So this is your solution. So you have infinitely many solutions because you can always add half a turn. So k could be 1, k could be 10 or 17 or -3. You just add 3, you subtract 3 half turns, or you add 17 half turns, and you're at the same point again. Look, take this here. You add 1 half turn, you're here, plus another half turn, you're here, plus a half turn, you're here. It's always the same tangent. Well, let's just switch on the 45 degrees. Well, I can't hit it anymore. Okay, so it's always the half turns. Now look, there is one interesting bit here. If you go in the second quadrant, your tangent will be negative. Same thing for the fourth quadrant. So tangent is positive in the first and in the third quadrant, because you jump by 180 degrees, and it is negative in the second and the fourth quadrant. Hope it wasn't too difficult. See you in the next one.